Okay, so first of all, there's just a couple more points I want to talk about unit testing and talk about mocks. I managed to get this working in a slightly more realistic way over the break, so I want to show you a little more practically what mocks are going to look like. So we're looking over here at my article page. So, previously in the use effect, when the page loads, we would be getting the article and then setting that in our state using Axios. So I want to be able to test this functionality. So instead of just hard coding the Axios request right in the use effect, I've defined a function, getData, which takes an article ID and it returns a promise, which should resolve to the data from the Hacker News API. And now we're exporting this function so that we can test it in our tests. So here in my unit.test.js, I'm importing getData. So we export it from the article page and I'm importing it. Now note, I'm also importing Axios. This shouldn't be necessary because I'm not going to actually call Axios itself from my code. I'm going to call functions that call Axios, but I still need to import it for the mocks. I'm going to refer to it. And now here is where we're actually using some jest mocks. So basically what this is saying is modify this module Axios that we imported just on the line above, Axios, and saying it here by name. It's modifying this thing right above it. Modify it so that it basically makes all of its methods mock methods of what's actually built in. It just replaces it with a fake version of itself. And so then later on in our code, we can tell the mock how fake Axios is supposed to work. So going down a little bit further here, I've got a little test that's supposed to test the data getting functionality. So we do call getData, which is the function that we imported from the article page. But before we just call getData, I'm configuring the mock a little bit. So, by default, Axios has this method axios.get. It does not normally have a method mock resolved value, but when I called jest.mock Axios and it modifies Axios, it adds a whole bunch of methods to it that let me configure the mock. And so this is one of those things that Jest is doing automatically, is that it adds this method mock resolved value. And so here I can specify what Axios should return. So this is basically saying that when I call axios.get, don't actually use axios.get, don't actually send an API request, just return this literal string here, okay, bye. So it's not actually doing any HTTP requests, which is much faster because I just want this test to be as fast as possible. And return a plausible value without actually testing the API. So we're going to await getData, and instead of using our actual getData function, it's going to use our mocked getData, and that just returns this okay bye. So then I'm expecting the value that I get from getData to be okay bye, what I said the mock should return. It doesn't even matter what I'm passing in to getData anymore, because the mock is just going to hard code return this value. And I guess that expectation doesn't really belong there. So yeah, you just saw the tests ran successfully. I'm just going to console.log. So we can see here the value is okay bye. It's not what getData usually returns based on the definition in the article page. Should usually return the response of this Axios get. But because in my test, I said that we are mocking Axios, And for this particular test, I'm setting the resolved value to be the specific string. That means that in this test, whenever I call a function that calls Axios, it's going to do this instead of what it normally does. So the problem I was having before is that this mock resolved value call, I had this up at the top of my file instead. So like that, just as soon as I say we're mocking Axios, and then this is what it returns when we mock it. I swear, like the last job I was working at, we used jest mocks in all of our code, and this was how we wrote all of our tests. It seems like there was an update to jest, and it no longer recognizes that. So now when you're setting the resolved values for the mocks, you have to do that inside of the test itself, which totally makes sense to me, because otherwise it's really easy to introduce bugs to your tests, where if I'm saying like up here that, you know, the mock should always resolve a particular value, and then if I forget about that halfway through my code, like then the mock is resolving some value that I'm not expecting it to. So now the way it works is that this mock resolved value is only valid inside of this test. So it's much less likely that I'm going to forget about it and it's going to mess up some other part of my code. Still frustrating for me though, just because it's different from how this used to work. But anyway, figured it out. So this is kind of more plausibly how mocks would work in a unit test. So I can run my test as fast as possible without actually, you know, touching the API. Does anyone have any questions about mocks or unit tests? What questions do we have?
Yeah, I'm wondering, do you end up testing the API call itself at some point as well, or do you just do it with the mocks functions?
That was a great question. That's actually the very next thing that I'm going to show you. Because as I've mentioned before, I really don't like working with mocks. I think that they're going to be the most complicated part of your test code and can potentially introduce bugs themselves. You're putting a lot of effort into testing something that is not your application, just so that your unit tests can run faster. Now, this is still a valuable test because it documents how the get data function works. So I was saying before that tests can serve as verifiable documentation. So in this case, it isn't exactly verifiable because this isn't the real get data function that's running. But at the very least, if I'm a new developer and I'm just like, I have no idea how this application is supposed to work, I can read the tests. And this is more or less documentation about how the get data function is supposed to work. But my preference is if I think that hitting the API is too slow to include in our unit test suite, I would just create a different suite of tests that are, you know, integration tests, and then test the API in there. So I'm going to make another test file. And these really don't belong in the pages folder. All right. I just wanted to test that I could run the tests, you know, from different folders, that the folder structure didn't matter too much. Oh geez, now everything is broken. Maybe I shouldn't have done that right now. So unit test.js. Oh, so it did update the imports, but didn't save my files and then automatically reran the tests. Okay, so everything is actually fine. Never mind. So I've got a new test file though for integration tests. So for my integration tests, I actually want to test multiple components at once. So I'm not just testing the get data function that it returns a value, but I'm testing that the get data function can call Axios, which sends an API request, and then we get a response from the API, which Axios can parse, and then the get data function returns a sensible value. So testing a few things then in this case. So I'm going to use the actual get data function. I'm not going to resolve value. So now this test is definitely going to fail. This is not a correct assertion, but it should get us the actual value of get data with this item ID. Yeah, so the response from the API is actually a very large object. It's not just going to be a string. Let's get some data out of this.
Could you just compare it to the ID that you pass in?
That's what I'm going to do. Ideally, I would like to test more things than just that. I feel like that's kind of a trivial test because like I just passed in the ID here and I'm expecting to see the ID here. So that's just like, can you give me the article that I requested? So it's definitely a test that's worth writing, but I would probably also have some other expectations like, okay, the article with this ID, like this article was by Robbie JS, I'm pretty sure. So I'm going to assert the author of this article as well. So we're going to assert that the ID is what I expect it should be. And that by is Robbie.js. Okay, so now the test passes. One problem though here is that I mentioned, this integration test is not quite as fast as my unit test. Generally, I want to group similarly paced tests together, tests that can run at the same speed, put them in the same suite. So probably not going to run the integration tests at the same time as my unit tests all the time. So I'm going to use, let's see here. So you can have just only run tests in a certain folder. So I'm going to put my integration test in this integration folder. Put my unit test, yeah, do it. Put my unit test over in this unit folder. Okay, and then I'm going to call npm test and specify a folder, only integration. All right, so now you may notice that it ran only one test because in my integration folder, there's just this one test suite and has only one test in it in this describe in it block. The unit test has a few tests inside of it, a couple tests. Integration test is only one. So in this case, I just wanted to run one test. So this is how I would do it. Now also practically, You don't usually write integration tests for a third-party API. You would write these tests for your own API. We haven't written our own API yet, so I can't show you that. But really, the way you write the code is pretty much the same for testing your own API as someone else's API. It's just that for someone else's API, you kind of trust that it does what they say it does, and you don't usually write tests for other people's code. But generally, the way you write the test is the same. You send a request to the API, you check what the value is, and you make sure it's what you think it should be based on the inputs that you passed in. So yeah, the integration tests are honestly kind of similar in a lot of ways to the unit tests. You're going to import some function, pass in a value, check the output, make sure that it is what you expect it to be. The difference being that the integration test is going to touch other parts of your system more than just being one pure function. So commonly an integration test is going to query your API. You're just sending a request, making sure you get the response back that you expect, or testing your model methods. So you're calling some function that accesses your database. So you're testing your Django code, but also how your Django code connects to Postgres and how you can run SQL queries against your Postgres database to make sure that's configured correctly. So that's a few different components that's tested together. So you would consider that an integration test. All right, so lastly, I want to talk about end-to-end testing. What questions do we have about integration testing before we move on? No questions? That's fine.
Yeah, I'm sorry, I'll ask one more. So ideally, would you want to run both unit and integration tests if you, in the case of a function like get data, or would you just pick one to run?
Are you saying how should we test get data? Should we test it in the unit test or test it in the integration tests?
Yeah, would you test it in just one or the other, or would you test in both?
I'm not sure. It's possible that you might find yourself working somewhere and they would tell you something different than what I think about this. But my opinion is I would test it in both places because both of those tests kind of accomplish something different. The API test is telling me, more certainly that the API is returning the data that I expect when I send the request that I send. But it's not always practical to really send an API request. If you're running your tests every minute or whatever, for some reason you're debugging something actively, you probably don't want to send that many API requests. Maybe you get rate limited, you get charged for it or something. So I would probably want to also have a way of testing that function that doesn't send the API requests, just to serve more as documentation, just to say what you put into this, what you can get out of it, and just make sure I can run that with all the other tests and it doesn't slow it down. So some people might consider that redundant, but I feel like it accomplishes different things if you have the test as a unit test versus an integration test. So it might be worth doing both. Although honestly, lots of places barely spend any time on testing. It's just not a priority compared with building features. So they might not write any unit tests just because you get more bang for your buck for an individual integration test. But that's, I don't know, that's an opinion. So yeah, I feel like I didn't really give you a hard answer, but I hope that helps.
No, yeah, that makes sense. Thank you.
Mm-hmm. Okay, so I made this new folder for end-to-end tests, where I'm going to try to test the entire application. Well, not the entire application, but I'm going to try to test an entire feature from the client to the server and back. So these are the slowest kinds of tests that I can write. We started with the fastest ones with unit tests. These are going to be real slow because I'm going to have to automate a web browser. But on the plus side, these are in my opinion, the best kinds of tests. They give you the most reliable information about whether your application as a whole actually works from a user's perspective. So you can drive a browser that clicks on links, submit forms, then reads text off the screen, and most other actions that a user would take interacting with your browser. So as far as automated testing, I think this is the best way that you can determine if your application like actually works. This is commonly called black box testing because when you write an end-to-end test, you don't have to know what the code is or how the application works internally. In fact, end-to-end tests are easily written by dedicated testing teams, by separate testers who maybe don't even know the language that the application is written in. They just have to know how the end-to-end testing framework works because it really tests the application from the outside. So traditionally, there weren't very many different tools that people used for this kind of browser automation. There was a tool called Selenium, which was kind of like the big dog in the room. It was basically your only option for browser automation. But fortunately, in recent years, there are a lot of other tools that have been developed that do pretty similar things. My favorite of these tools by far is Puppeteer. So we installed that with npm install Puppeteer. So just like someone holding a marionette and making that puppet dance around and sing or talk or whatever, this is a module, a library we can install that lets us pilot around a web browser. Now, traditionally, one of the hard things about these kinds of browser automation technologies is hooking it up to the actual browser. So you have to, install like Selenium itself, and then you have to know which browsers it can control, like Firefox or Chrome, and install the right browser, and then install like a connecting software between the browser and Selenium. So Puppeteer lets us skip a lot of steps because it comes bundled with its own browser. So when you install Puppeteer, I'm going to do that right now, in addition to installing a node library, some JavaScript code, it's installing an entire web browser. So it's going to install Chromium, which is an open source version of Google Chrome, but it's going to install a very specific version of Chromium that integrates perfectly with this version of Puppeteer. So it's a little bit wasteful because like I'm installing an entire browser just now to install Puppeteer. And I'm like, why would I do that? I have all these browsers already on my machine. But it really saves me a lot of steps in configuring my browser automation. So I really appreciate what Puppeteer does for me. All right, but let's see what this actually does. How does this actually work? So first of all, we're going to have to add, let's see, first of all, we're going to have to import it. So we're importing it just like any other node module. But now we can't just go and write tests right away immediately. We have to do a little bit of setup. So I believe we saw something similar to this when working with Django. We're going to see some similar setup tools for our JavaScript-based testing environment. I'm going to declare a before all function here. This takes a callback function. So basically what this is saying is that before all of the tests in this describe block, so I've got at least one, but there might be others, before all of them, we want to run this function. What we're going to do in this function So we're going to create a new browser. We're going to launch Puppeteer. And I'm going to add an option here, headless false. So headless means, should it be visible? Should we actually be able to see the web browser? By default, Puppeteer tries to run as fast as possible. So it doesn't actually graphically render the browser as it's automatically traversing your web application. But that's not fun. I think it's really cool to see the browser moving around really fast. So we're going to disable headless mode just for the purpose of this demonstration so we can see what Puppeteer is actually doing. And then also, after we create the browser, we're going to create a page. So this is basically just like opening a new tab in your browser. We call the new page button on the browser object, and that gives us a page object. And then we will navigate to our local application. So this does mean that I need to run the app in advance. All right, so I'm running the app now. Because I'm going to send a browser to this URL. So there needs to be something running at this URL for my browser to see it. But this is all the before all. This isn't the actual test. So let's see, what can we actually test? Let's see, what do we even have on the home page? Let's see. Let's just check if we can find any of these links on the page. So we've got a whole bunch of links. They have these classes even item and odd item. So I'm going to look for those. Generally, adding classes or IDs to your elements makes them easier to identify in your tests. So even if your application itself doesn't rely on classes and IDs, it can make your tests a little bit easier to write. So the homepage should render articles. We've already loaded a page to the home page, so we just have to check it now. So first thing, problem with automating browsers is they'll often run too fast. And so you have to make sure you wait for the content to load before you actually run code that looks for it. So Puppeteer has a lot of methods that let you wait in different ways. We could just say like wait for half a second, but that's not very smart. So this is a little bit more common. We say wait for selector. So I call this method with an item with a CSS selector that might not yet exist on the page. So all these even items should have this class .even item. But while React is still like starting up, in the first like second that the page is loaded, this doesn't exist yet. So I'm saying that we have to wait until this selector is selectable, until this returns more than 0 items, and then we can continue. So next, I want to try to see if we have any links. So I'm going to try to select an element on the page in my automated Puppeteer browser. So I'm going to say page.$, and then I just pass in a selector here, a CSS selector, and that'll select the item. I know we didn't cover Jquery in this class, and I might have mentioned it once, but for the longest time, Jquery was pretty much the only front-end library that people used. And a lot of that code was just about selecting elements, and this was how that was done. The whole Jquery library was just in this $, and you would say $, and then some CSS selector, and it would grab that item for you. So for a lot of web developers, this syntax is just permanently burned into their brains, and they can never forget this. So just the idea that you say like $, and then a CSS selector, and that's how you get something off the page. That's a very common pattern, I think, to a lot of front-end developers. So this gets us a link. But it doesn't give us the actual HTML element. It's like something that kind of represents the HTML element. So we have to run a little bit of extra code to get the actual value out of it. So one of the tricky things about this kind of browser automation is that we have two different JavaScript contexts. Obviously I'm running this, this is a JavaScript file. I'm running this at the command line. So this is all a JavaScript file, and there are JavaScript variables that are defined here. But also I'm creating a browser when I run this code, and that web browser runs its own JavaScript. So when I call link.evaluate here, I am not running this JavaScript code locally. I'm running this code in the Puppeteer browser. So I want to get the inner text of the link element that we selected in the Puppeteer browser. And this is kind of the official way that you get that information. You can get these snippets from the docs. So I didn't, make all this up. Yeah, this is what it looks like. So let's just console.log the link text. And I think there has to be some kind of assertion here. So I'll just put a trivial 4 is 4. Great. So let's run the end-to-end test. There. You see that browser pop up. It goes to localhost 3000. It's complaining about a timeout. What's going on here? I think that I'm forgetting to close the browser. So before all, we open the browser, but we need to close it when we're done. Otherwise, it just stays open forever. So I'm going to define an after all method. So this one, I'm going to define it a little bit differently. So this one is not an async function. But also, this one is going to take one argument called done. So normally Jest knows when these functions are done, just when it gets to the end. it's finished. Sometimes if you're doing asynchronous work, Jest gets confused and it doesn't actually know when your functions are finished running, and it thinks the test is hanging when you're actually done. So this is an optional syntax in Jest. You can pass in this done function, and then I'll call it to let Jest know, like, okay, now this function is done. Please move on to the next step, because sometimes it doesn't catch that automatically. But all we need to do here is close the browser. So in theory, that should actually clean up our tests properly. Yeah, there we go. Okay, nice. So you saw the test ran, the link text, 300 drums, 400 QR code, Rickroll Dallas on April Fool's Day. And then after the test runs successfully, we close the browser. So that's cool. We're able to get text from a link. We want to actually like navigate this app a little bit more like a human does. So what I want to know now is I want to verify that I can click on one of these links and then it takes me to the article page. So the way I have this set up is, I click on the link in the article teaser and it takes me to this very brief article page. Excuse me. There's almost nothing here except for the title and the date and the read the full article link. So, this has to go through a bunch of like props and state in order to render this link properly. So I want to make sure that, that part of my application is working successfully. I want to verify that I can click on one of these links and then I will see this button on the next page. So we don't actually need to manually grab the link like that. I'm going to do now, wait, page.click, even item A. So now if we look at the page itself, check out the markup. I should get out of here. So that's a selector that describes our anchor. Inside of something with the class even item, there's an anchor, and I want to be clicking on this anchor because that's going to let me navigate the page to somewhere else. So we're going to await page.click even item A. And now it takes a few milliseconds for the page to load. So if I just try to run some code immediately, nothing's going to exist yet. So I need to wait. So I'm going to wait until something with this ID exists on the page. Sorry, the tests run automatically every time I save, so that's why the browser keeps popping up. So yeah, these guys all have this anchor with the ID read more. This ID is not actually used in the application anywhere. I just added it to the anchor for the purpose of testing so that there would be an easy way to select it. So there's an easy way to know it exists on the page. This is a trend you might notice going forward, is that writing testable code is harder than just writing code, that there's a specific way that you need to organize things so you can export individual functions, or so that you can select elements on the screen that you should be looking for. So even though it's not part of the application, I add this ID just for my tests here. So we're going to wait for selector, and then when that read more link exists, let's say Okay, so I'm going to grab the read more link. Wait a second here. Sorry, I think I missed a step here. Click even item A, wait for read more. Next link is more. Okay. Now I'm going to expect that the next link text is actually this, read the full article. Okay, looks like that worked successfully. I kind of don't believe it, so I'm just going to console log this value anyway. So yeah, the next link text is read the full article. So I was able with my browser to first wait for the page to load. And then we click on the first anchor inside of an even item. And then we wait until we can see the read more link, because I'm expecting this link to be on the next page after we click on this item. We fetch it from the page, get the text out of the element, and then compare that text with what we're expecting it to be. So this is a pretty basic end-to-end test where I'm, forming some assertion about how the UI should work. I should be able to load this page, click a button. It should take me to some other specific page with specific content on that page. And this is how I verify that. Kat?
Can you just summarize the part that you commented out? How does that relate to what you have not commented out, I guess?
Mm-hmm. So this part here is just to read the text of the first link, but for this more full demo, I don't really care about the text of the first link. I'm just clicking on it. So all I want to do is click on a link. All I need is await page.click and then the selector of the thing I'm clicking on. For some reason though, to get the text of it, that seems like it's a little bit more complicated with Puppeteer. So after grabbing the item, you can't get the text itself from just this item, but you have to run evaluate on it. So it's running code in the Puppeteer context where you can see the actual text of the element. I feel like there's got to be a more elegant way to do this, but not from what I've seen so far.
Okay, so what you didn't comment out or what you did later is kind of another way to do it, basically, or to kind of get to test for the same effect that you were looking for. Is that right?
I mean, I'd say here I'm testing the text of a different button. First, initially I was just examining the text of these links here. But then for the second version, I decided I don't actually care what these links say. I just want to click on one of them, the first one. Actually, I think I clicked on the first even item, so that would be the second item. And then I want to read the text of this link. So previously it was read the first link, and now it's click the first link, read the second link.
Okay,
Cool.
yeah, that makes sense. Thank you.
Cool. Andrew, did you have your hand up?
Yeah, I think you answered it. This one can only click on the first one that pops up, right? For even item A.
Yep. So that's just how Puppeteer works. If you give it a vague selector that matches more than one item, like even item A, there's a bunch of those, it's just going to do the first one. And note that there are also different ways of selecting things on the page. So page.dollar will select a single item. Page.$$ will select all the items that match this selector. And this is all in the Puppeteer documentation, which I hope you'll read this afternoon, but it's definitely pretty thick. So I'm trying to give you some clues up front. Yeah, was there another hand up? Could have sworn I saw someone. No. All right. Okay, so those are the three main types of testing in a nutshell. I honestly kind of prefer end-to-end testing just because it gives you the most certainty that your application is actually working correctly. There are a lot of reasons why your individual components can return the correct values based on their inputs, but your application as a whole still doesn't work. So I think automating a browser is really the best bang for your buck in terms of like determining if your application actually works the way your users expect it to. Unfortunately, these are slower tests. So that's why I put this in a separate folder, because when we're running the unit tests, those are going to be really fast. I don't want to slow that down with these browser automation tests, which, by the way, if you want, we can actually slow these down even more. So I added this slow-mo variable to the Puppeteer launch. This makes the browser like run even more slowly. So like if it was filling in a form, we could potentially like watch it typing character by character. That can be useful if you have bugs that are related to timing. Sometimes you'll have bugs that don't exist when your feature is used quickly, but when it's used at the pace that a human would use it, then the bugs will actually occur. So let's talk a little bit about, now that you've seen these three different types of tests, I want to kind of back up a little bit, zoom out, talk about some more general testing concepts. So there's this question of how many tests should you write? I see a lot of dev shops kind of aspire to 100% test coverage is what they say. In my opinion, that just doesn't make any sense at all. Like from a philosophical perspective, you cannot test 100% of an application. You can maybe write a test for every function in your application, but that's not the same as testing every possibility, every code path, every input that you could possibly have. Because really your application behaves differently, based on user input, and you can't control what they type. Based on the day of the week, honestly, your application will behave differently. I saw some really like funny Hacker News article last month about some crazy bug that only happens on like the second Thursday of the month in some weird application. So not that that's super common, but these things can happen. It's not impossible. So as you might have noticed, it takes time to write tests, even just initially. But once you finish writing the tests, you're not done because you have to maintain them over time. So as your company grows, as the requirements change, you're going to have to update all the old tests. So the more tests you have, the more of a maintenance burden that is. Tests themselves can have bugs. So, the more tests you write, the more likely it is that there will be a bug in your test, which causes other problems like false positives or false negatives, which are even worse. There might be a real error in your code that you don't catch because your tests are buggy. And also the more tests you have, that increases the length of your test results, which just makes it harder to read. If you have 1,000 passing tests and one failure, you need the output to be really legible so you can read that. It also increases the amount of time your tests take to run. if you have 10 times as many tests, they're going to take 10 times as long to run. I don't think there's any way around that, really. So my point is just that writing tests is expensive. Not that you shouldn't do it, but you need to make sure that you're getting more value from your tests than what it costs you to create. So you should, prefer testing important features of your application. So sign up and login is probably the best example of an important feature, because most applications are generally worthless if people can't log in. And there are a lot of reasons why logins might fail that have like really nothing to do with your backend functionality. I've seen applications break, nobody could log in because of a CSS bug. Just the form for the login, it was working perfectly fine. It was just rendering off the side of the screen where no one could type into it. So that's not the kind of thing that you'll catch in an integration test, but maybe an end-to-end test that is actually automating a real browser could verify that the login form is on the screen. And then on the flip side, your website might have an admin dashboard that's just like a convenience for employees to manage the app. And you might have a CSS bug on there that causes something to be like 2 pixels off to the side. And that's definitely not worth testing, because like if that breaks, there aren't really any consequences. It's very low priority. And the cost of maintaining a test for that feature is probably higher than the value you get in having that CSS rule be tested. And also generally you should get good at writing tests so you can write them quickly and efficiently, because then the less effort you put into writing a single unit test, because you're good at writing tests, the better your cost benefit analysis becomes. You'll appreciate the limited benefits of a unit test more if it costs you very little to write them. If you feel like you're bad at writing unit tests, you're probably not going to appreciate their value as much. So, just practice them. They should become familiar to you. Let's see. So now there's a question about when to write tests. Let's actually write this down. So just in even the timing of when you write a test, there are some different ways that people do this. The basic strategy, this doesn't really have a name, but this is like literally what I've done almost everywhere I've worked. Write tests after you complete a feature to make sure that it works, won't break in the future, and to document what you did. So this is pretty important, the last part especially. In a lot of teams, like you're going to get your tickets written by people who maybe aren't even software engineers. You're going to get your pull requests reviewed by people who aren't actually running your code. They're just kind of like reading it over for a few minutes. And so it's really good if you can do as much as possible to help other people on your team know definitively that like, yeah, your code works and this is how it works. So in part, people will write unit tests after they finish a feature just to prove to other people that like this is what it does and it does what I say it does. Another, I'm not even going to call this a strategy, but this is something that happens sometimes, reactive test writing. So like I've said before, the most embarrassing bugs are the ones you've already suffered from in the past. So generally speaking, if you're dealing with a bug after you fix it in production, you should write a test to make sure that that specific bug can never happen again in your application. And then this is another reason why I think it's valuable to read the tests when you're on a new team, because that's going to give you some clues about things that they've struggled with in the past and things that you should be watching out for in the future, perhaps. And so third style for test timing is TDD, S-Driven Development. So I'm sure we've talked about this before, but this is where you first write a test after you write the test, you know it'll fail because you haven't even written the application code. All right, so first you write the test, it fails, you write the application code afterwards. For the longest time, a lot of software quality proponents were saying that this is the one true way, the best and only way to write your code. But over time, I think people have discovered that nobody actually does this. Like, everybody wants to talk a big talk about how like disciplined they are and how just like proper they are in these best practices, but like legit, nobody does TDD practically in like any dev shop I've been to. There's trade-offs to any decision, and I'd say in TDD, the trade-off is slows down development, but it reduces bugs. So depending on what you're building, this is the trade-off you want. Like if you're building a medical device or security systems or whatever, you probably don't release a new version every week, but you had better be damn sure that like there aren't any bugs in it, or someone's going to die or their house is going to catch on fire, something like that. So in those situations, it's worth slowing down a little bit. Unfortunately, I think the reality is that for most modern tech companies, they are financially incentivized to just pump out features as fast as possible. And when there are bugs in their code, even when they're very visible bugs that like stress out users, there aren't actually financial repercussions for the company. So like there aren't the right financial incentives to encourage companies to spend more time on testing instead of feature development. So that's why you're probably going to end up working on a buggy application in whatever job you end up at. Not that there isn't literally time to write tests, but any time that there is available for writing tests, like could be spent more profitably on developing features generally. So I'm sorry and good luck. Kat, do you have a question?
Yeah, just like based off of what you were just saying, do you think then like in consultancies, it's more important for them to write tests because like it has to work, or like their company's not going to get hired again?
Oh man, that's a really good question. I want to agree with you and say that like, yeah, because it's someone you don't have a relationship with, you don't know if they're good coders and you don't really know what they deliver to you. Like, yeah, it would be really nice if they had robust tests to prove that their product works and to tell you how it works. I have very limited experience with getting deliverables from contractors like that, and I've been generally disappointed. So I want to say like practically, if I was a gambling man, I would not bet money that some random contractor is going to include robust tests with their application. But in an ideal world, I think that would be good. I think it would be more important really for a third-party contractor to have good tests than someone in-house, just because you don't have that personal relationship and they need to communicate better, and tests are a good way to communicate. So yeah, definitely a good question. Definitely something to be thinking about. Sorry, I don't have the right personal experience to really answer that definitively.
Oh, thank you.
Yep. There was another hand up.
Yeah, so you were talking about how like it's always pushing the rush features out. So you're saying in like the real world, like what's the word? Technical debt is like more like the norm than like the exception.
Yeah. I think I once interviewed at one company where they said that they spend like one day every 2 weeks on just reducing technical debt. But like in most companies, it's just like technical debt accumulates until the developers can't stand it anymore and they quit. And then they just hire new people who aren't aware of how bad the technical debt is, or the new people just rewrite the app entirely. It's easier to just like churn through junior developers than actually build an application that people want to work on long term. I'm sorry if that's kind of cynical, but like, yeah.
It's just reality.
Yeah, positive developer experience is not what pays the bills. That's not what drives revenue. Which in general, I think is kind of a hard thing to think about as an engineer, because we're like so grossly overpaid as far as like individual contributors go. But I really believe that like the success of a tech company is only indirectly related to the excellence of their engineers. And that I think a lot of engineers tend to overstate how important they are for the business's success. That's just my opinion. Do you have any other questions? So the very last thing I'm going to talk about today in terms of testing, there's the question of when do you run your tests? So kind of the most basic approach to this is run the tests manually after making major changes and before you deploy. Ideally, though, what you'd like to work towards, and this is something a lot of modern tech companies do, is called continuous integration. This is commonly just abbreviated to CI. And there are a lot of like apps or software services that provide this. So you might have heard of like Travis CI or Circle CI. And I think GitHub is now offering its own CI platform as well. But so continuous integration basically means that you are like constantly and automatically building new versions of your application, which means that you're automatically running the tests. So imagine like if your company depends on manual testing, you might take like a month manually testing your application before you deploy a new version just to make sure it's good to go. But if you have robust automatic tests, you know, it takes maybe an hour to run like all of your tests, even like the really slow ones. And then after that automated test, you can be pretty confident that the app is good to go. So if you have really good automated testing, that enables you to redeploy your application like on a weekly basis. Some people I think even deploy daily, which I think is insane and unnecessary. Like nobody asked for that, but deploying weekly can be pretty useful and pretty cool. Just because it reduces the difference between each deployment. So you're making small steps forward instead of having like major version differences. But also when you run your tests depends a lot on how fast they are. So I was saying before how the speed of your tests is really important and how I don't really care as much about like the pedantic differences between a unit test and an integration test. And like some people can argue about that all day and it doesn't actually like solve any problems. So what matters to me is how fast they are and that you group similar speed tests together. So because if tests are fast enough that they can run in seconds, like, you know, an individual unit test just calls a function with input and output. There's no database, no API. That's like a microsecond to run that one test. I can have like 1,000 unit tests like that and they'll execute in the blink of an eye. So this is something that I've seen some people like to do. They'll configure their editor to run the unit tests when they save the file. So like already, you know, we have our console here that gives us information if it like fails to compile the React app. In Django, we had similar information, tries to compile it and tells us if it detects any automatic errors. So we can add a layer on top of that. We write our own tests and then configure our editor to run them every time we save a file. So we can get that immediate feedback like, oh, hey, you just wrote something that broke something else in the application. So you don't have to, get 2 hours into your development before realizing that you made a mistake that you're gonna have to fix somewhere else. The test tells you immediately. So for the integration tests, it's really unlikely that you're going to get the integration tests to run in under a minute. Just the API requests can take a couple seconds. And then if you've got a whole bunch of them in one test suite, it's just really hard to make that fast enough. It's going to be under a minute. But if you can make it under 10 minutes, at least just a few minutes. So it's fast enough you wouldn't mind doing it a few times every day, but not like every 10 minutes. You can configure Git so that it runs your tests every time you commit. So I think we showed you before the Git hooks directory. Let's just take another peek at that real quick. Okay, so here I'm in the .git folder for my demos Git repository. I know in our first Git lecture, we showed this to you and didn't really dive too deep into it. So this is the internal workings of Git. The only folder here I care too much about is hooks. So this is where we can set lifecycle hooks for Git. So like I was saying before, pretty much every software framework is going to have lifecycle hooks. And it's just kind of unfortunate that React uses the word hooks to refer to something else. But so here, this is hooks in the traditional sense, before React started using common words for specific technologies. And if we look in here, the hooks, these are a bunch of sample scripts that run at specific times. So we can run a script when we have a commit message, after we update, before we commit, before we merge a commit, all these different lifecycle events in Git, we can write our own code that runs when those events happen. Excuse me. So I want to say pre-commit is the only one I've ever actually used, but you can use this to like, make sure no one is pushing directly to the master branch. So you can have a pre-commit hook there and be like, no, you can't commit directly to master. We're going to error out and cancel this operation because you can only update master by merging pull requests generally. But you can also have this pre-commit hook just like run the tests, just npm test. So this is just that example Git hook. It's just a bash script and it just runs anytime you commit. This is doing some Git specific stuff. So your actual hook script might look even simpler than this. But you don't really need to worry about that too much right now. You can look it up at the time when you decide you need that. The point is just that you've got options for when and how you run the tests, and you should be thinking about automation. You don't want to have to remember to run the tests because then you might forget and then bad things happen. You want to set up automated systems where these tests are run automatically. And then ideally, you can also automate decisions based on the test results. Like if you run the tests in CI, then someone might press a button to deploy the application, but it doesn't just blindly deploy the application to your server. It's going to run the tests first. And if the test fails, your DevOps guy is going to get an email saying like, hey, the test failed. We can't deploy the new application version. Please check it out and fix it. Maybe talk to the developers or whatever. So that's definitely like a really important part of modern engineering organizations is this kind of automation with the testing and getting the results to the people who need them. All right. So you're gonna have an exercise tonight. We're gonna ask you to write some tests for your news site application. So the requirements are fairly vague. So you don't actually need to have reached a specific milestone in your news site application. Just whatever functionality you've got, write some tests for it and make sure it does what you know it should do. Also, I was kind of expecting that people were going to get stuck on some of the finicky bits of the homework tonight. So I didn't want to push you too hard. So if you got stuck on something low level, you could focus on whatever it is that's getting you stuck. Let's see if we can see that. So yeah, I want you to add 3 unit tests and 3 functional tests. This looks like very little, I think, but for the unit tests, you might actually have to refactor your application. So it's not just about like writing a couple of tests in a test file, but I'm guessing that many of you, the way you wrote your code in the first place, it's not testable. So I know mine wasn't, honestly. I had to refactor my news site in order to make it easily testable so that, you know, I was using more small functions that just take input and return output. So ideally, you're only testing those pure functions that don't have side effects. But you know, you might not have enough small functions like that in your application. So if you end up testing the API calls, you're probably going to want to use Jest's mocks in order to make that more efficient. I added this as a bonus because I think working with the mocks is a huge pain in the butt. And I'm kind of expecting that most of you are going to struggle with it, even if you're following along with me today. And then similarly, just want you to add 3 functional tests, you know, just verify that there's an H1 on the home page. You can click a link and it goes to another page. We don't even have a sign up form yet, so these aren't going to be very sophisticated UI tests. Generally, a really good UI test would be to fill in and submit the sign up form or the login form and verify that you're actually able to get to the home page. But we're going to make it even easier than that because we don't have a database yet. Just the point is just, can you use Puppeteer at all? Just getting to use it in a basic sense is kind of tricky. Even though this is, you know, way easier than Selenium to use, it can be a little bit rocky figuring it out. So we linked to the documentation for it. They've got a lot. Honestly, just looking at how small the scroll bar is on the right side makes me kind of intimidated, just knowing how far I can scroll. But it's organized pretty well, I think, by classes here. So if we look at, where'd you go? Here, so the page class tells about all the things we can do with the page. So page.evaluate was that generic, just run code on this other JavaScript page. You know, page.dollar lets you select elements on the page. There's a whole bunch of other things here. There's the browser class for opening and closing the browser. And then the global Puppeteer class. So definitely a lot of docs. You might have a hard time just reading through them from top to bottom because there's a lot here. So, you know, feel free to search. So, you know, I want to know how we can wait for things. There's a few different waiting methods: wait for target, wait for navigation. You know, if you're like clicking a link that goes to a different page, there's apparently a method specifically for that. Also, just Googling is pretty helpful. Puppeteer is a pretty popular library. So you'll probably find a lot of Stack Overflow questions with people having problems with it that might help you out. Yeah, so it's definitely a lot of fun. Like, I really enjoy Puppeteer. I really enjoy browser automation. A lot of my like personal projects on the side will often involve browser automation. Like I use this for web scraping a lot. If you want to like get data from a website but they don't have an API, well, like you can't just send an AJAX request to them, but you can automate a browser to just visit that website like a human would and then load the page and then get data off the screen and then send it back to your application. It's definitely like a lot more work, but it is technologically possible. And so like, I'm pretty sure that that's what Google has to be doing. Because in order to index the whole web, they've got to have their crawlers going to all these different websites and checking out the content on them. But since so many websites these days have their content rendered with JavaScript, you can't just like send an AJAX request and get the HTML content, because it's just going to show you like an empty app div. So Google, when they're crawling like more important sites that they want to have better information about, they're actually going to be like automating a browser or something like a browser that can run JavaScript. So you could do stuff kind of like that with Puppeteer and just, crawl the internet, get random data from random web pages. Okay, so that's basically everything I know about testing. What questions do we have? Chat is like blowing up, so I'm going to be a little bit disappointed if nobody asked any questions right now.
You got to give us time to absorb this all.
I know it's a lot. I just assume, when there's like 88 unread messages in the chat, I'm hoping that at least one of those is a question that I could maybe answer for the class. But maybe just need to let it marinate for a while before we know how to articulate our confusion.
So, I mean, I know this is something you kind of covered pretty much, like more or less said it, but for content aggregators, is this more or less how you would assume that they're getting a lot of the content that they have?
It depends, but I would kind of hope not. For most content aggregators, I would hope that there's like an API that they can use to get the data. Like, Reddit, for example, has an API. So if I was going to build a Reddit clone, like I wouldn't just scrape the screen to get news stories from Reddit. I would use their API to request the JSON data. So that's going to be like a lot faster in general, I would say. Yeah, if you were trying to make like a big aggregator site that just relied on screen scraping, it would probably be very slow. So depending on what data you need. Yeah, I know. It might not work out very well. It might not have a great user experience. I used to know a guy actually who was a professional scraper because he would just scrape Craigslist. Because apparently there's like a market for that. There are a lot of people that want to get automatic access to Craigslist postings, but Craigslist actually does work to prevent people from scraping their site. So if you understand like the scraping prevention technology that Craigslist uses and you know how to circumvent it, apparently that's not illegal. It just violates their terms of service, which I don't think you have to really care about. It's not your problem, because I don't have a contract with Craigslist, but yeah, so apparently if you know how to get around their scraping prevention, there are people who will, pay you for regular, steady access to a stream of Craigslist data. So like in that case, I'm not sure if people post to Craigslist quite as often as like a lot of other content aggregators might be looking to get new content. But also just because there's more value for the individual piece of content in that case, like I'm saying that there's a specific buyer who is paying you to scrape content from Craigslist. In that case, it's probably worth putting the extra effort in to scraping Craigslist. But like if you're just making an advertising supported site, like just like YouTube or something, but instead of having your own videos, you're trying to like scrape them from somewhere else, that's probably not going to work out very well. Just because like you just need more visitors, more views, and more money, and you're probably not going to be able to make that work on an advertising model. So yeah, just based on the economics of that, I wouldn't think that like a content aggregator would use screen scraping. but sometimes it's the right choice. Sorry, again, that was probably way more of an explanation than you were asking for, but I just think it's an interesting question to think about. What other questions do we have?
Just said thank you.
Oh, cool. Yep, you're welcome. All right. So I'm getting the sense that we don't have any more burning questions right now. And this has definitely been a lot of lecture already today. You know, this is part 2 from the morning. So I think we're gonna break now if we don't have any more questions. I'm gonna generate some pairs for, you know, what time we have left in the afternoon for pair programming. And then we can get on with our evenings. And then stand down will be at 5. It'll probably be fairly brief though, given, you know, all the extra content that we've covered now, unless people have specific questions. So, you know, do please come with specific questions if there's something you'd like to see covered at stand down. All right, other than that, I'll catch you all later. Thanks, everybody.